Okay, guys, so this is the lecture from section 11.2, linear equation, two variables. So I started with definition, of linear equation. Linear equation in two variables is the equation which has the form ax plus by equals c. A, b, and c, they all represent real numbers, and such that since we're dealing with linear equation, a and b both cannot be equal 0. And the solution of linear equation is order per x comma y. So let's start with the example. Example 1, determining solutions to a linear equation. Okay, so we're going to do a couple of examples here. Let's start with A. Given the equation, three x minus 2y equal negative 12, we have to determine whether the given order pair is a solution. And what they're giving you, they give you 0.4 comma 0 for number 1. For number 2, they give you negative 2 comma 3. Okay, so again, what we're going to do, we're going to check in number 1 if 4 comma 0 it's the solution of the equation 3x minus 2y equal negative 12. So let's do number 1. So first, replace x with 4, y with 0. So we're taking that equation 3x minus 2y equal negative 12, and we have 3 times, we're replacing x with 4, so we have 3 times 4 minus 2 times y, we're replacing y with 0, and we're going to check if that will give you negative 12. So we end up with 12 minus 0. It's supposed to be equal negative 12. We end up with 12 equal negative 12. So since this is not true, okay, 12 is not the same as negative 12. So 0.4 comma 0 is not a solution of the given equation. Okay, so let's do number 2. So let me just separate that. So we're going to do the same thing. We're going to replace x with negative 2 and y with 3. So our equation will become 3 times, we're replacing x with negative 2 minus 2. We're replacing y with 3. And we're going to check if this is equal negative 12. So we're checking that. So we end up with negative 6 minus 6, and that's equal negative 12. So since this is true, okay, so going back to the lecture, so we just show, after replacing x and y with coordinates of the given point, that we end up with a true statement that negative 12 is equal negative 12. So the point negative 2 comma 3 is the solution of the equation 3x minus 2y equal negative 12. Okay. So that was the example of how you're going to show that the given point is the solution of the equation. Next in this section, the second objective is about graphing linear equations. In two variables. By plugging points. Okay, so let me just give you a note that to graph the linear equation, so graph of linear equation is a straight line which is created by all ordered points let me just say better, by all ordered pairs per solutions to the given equation. So what we need to understand about linear equation, that the graph of the linear equation is a straight line which has infinitely many points. So the solution of the linear equation, it's infinitely many solutions. So that's all the points from the straight line which satisfy the equation. So let me explain that using example 2. We're going to graph a linear equation and don't forget that you're graphing your linear equations using Alex. So you want to navigate that graphing tool. So you have 2x plus y equals 6. So how are you going to graph it? So first, you want to create a table. Okay. So your table will have 3 columns, x, y, and maybe not y, x. Then the second column will be the equation, 2x plus y equals 6. And the last column will be the order pairs, x comma y. Okay. So for x, to graph the straight line, you need 2 points. I usually are going to find 3 just in case if we messed up or did algebra mistake. So for x, you can pick any x you want. Okay. So let's choose x being equal -1. Okay, because x are the independent variables. So to find y, we're going to replace x from the equation with -1. So we have 2 times -1 plus y equals 6. And you want to solve that for y. So I will just show work on a side. So we have 2 times -1 plus y equals 6, which is -2 plus y equals 6. Solve for y, we're adding 2 to both sides and you're getting y equal 8. Okay, so here again, if you solve that, you'll end up with y equal 8. That means we have the first solution of that equation, -1 comma 8, which is also the point of the graph of the equation. Okay, so what we did first, we create the table. Second step is pick at least 3 values for x, three arbitrary values for x. And the third, it's going to be replace x with the value you pick. So it's going to be replace x with the value you pick. And solve the given equation for x. And of course, the fourth step will be plot the points. X, Y. Okay, so the next value for x will be 0. So I'm replacing x with 0. So we have 2 times 0 plus y equals 6. When you will solve this equation for y, we will end up with y equals 6. So we have a point 0, comma 6. And let's just do one extra point. Let's pick for x1, let's make x equal 1. So we're replacing x from original equation with 1. So we have 2 times 1 plus y equals 6. Solve this equation for y, and that will give you 4. So we have a point 1, comma 4. So we have 3 points, and now we're just going to graph it. So we draw the coordinate plane. So you guys won't have to do that by hand. You will use Alex graphing tools for graphing, but let me plug in the points. So we have -1, comma 8. So the first point was -1, comma 8. 1, 2, 3, 4, 5, 6, 7, 8. The second point was 0, comma 6. 0, comma 6. 1, 2, 3, 4, 5, 6. And the last one was 1, comma 4. So 1 on the x-axis, and we're going up 4. 1, 2, 3, 4. 1, comma 4. Okay. And the graph creates those 3 points are just examples of infinitely many solutions, but the graph of the linear equation is a straight line. So this is 2x plus y equals 6. And I want to explain it that every single point on the straight line is the solution of the linear equation. Okay. Okay, I think that's enough from graphing. Let's just move to x and y intercepts, which is objective number 3. So next I'm moving to the third objective from this section, which is x and y intercepts. Okay, so I'm going to start with a definition. An x-intercept of a graph is a point a, comma 0 where the graph intercepts or touches it can be intercept, sometimes it can be touch. The x-axis. With linear equations, you always have intersect, but when we will be talking about graphing quadratic equations later on, or in college algebra, it's going to be attached sometimes. So the x-intercept, I'll just give you the example. You have the coordinate plane, and let's say you have a graph which looks like this. So this point right here, it's the x-intercept. Okay, so this point has coordinate a comma 0. Like you see, the y coordinate is always going to be 0, and this point represents x-intercept. So always in x-intercept, y coordinate 0. Remember that. Now let me give you the definition of y-intercept. Y-intercept of a graph is a point zero comma b where the graph intersects the y-axis. So must be on the y-axis. So let's quickly graph it again, show the example. We have y, x. Let's say we have a graph which looks like this. Okay, that's the graph. So this point on the y-axis, okay, so it's a y-intercept. It's the point when the straight line intersects the y-axis. So this is the y-intercept. And the y-intercept always have coordinate 0 comma b. So 0, that's the x coordinates, always equal to 0. Okay, the y coordinates, just again the point on the y-axis. Okay, it's the coordinates which you read from the y-axis. Okay, so we're going to find x and y intercepts. So let me give you a note. To find x-intercept, substitute y with 0. So you're going to substitute y with 0 and solve the equation for x. And solve the equation for x. So that's what we do to find the x-intercept. We substitute y with 0. And to find y-intercept, we're going to substitute not y, but x, substitute x with 0. And solve the equation. So to find the y-intercept, we're going to substitute x with 0. Okay. Okay, so let's make the example. Given x minus 3y equal negative 4, we need to find x and y intercept. So we have to find x and y intercept. Okay. So let's start with finding x-intercept. So again, x-intercept. How are we going to do it? We're going to make y equals 0. So we're taking that equation, which is x minus 3. We're going to replace y with 0 equal negative 4. And we're going to solve this equation for x. So we're getting x equal negative 4. So this one is the x-intercept. Is the x-intercept. When you're solving problems like that, pay attention on Alex, how they want you to enter the solution. If they want you to enter the solution using the coordinates, which is the order pair, so you will put that point negative 4 comma 0 is the x-intercept, okay? And we know that because x-intercepts, that's the point on the x-axis, so always y coordinate will be equal 0. And what we're going to do next, we're going to find y-intercept. So for y-intercept, we're going to make x equals 0. So we're going to work with our equation. You're going to substitute 0 for x and just follow the rest of the equation. So 0 minus 3y equal negative 4. We have negative 3y equal negative 4 and just solve this equation for y. And that will give you y equal 4 over 3 is the y-intercept. And again, sometimes they want you to put the solution using order pairs, which means 0 comma 4 over 3 is the y-intercept. Okay? And when you have x and y-intercept, it's super easy to graph. So to graph equation, the one which we're working on it, which is x minus y equal negative 4, use x and y intercepts. So to graph the straight line, you just need 2 points. So we're going to graph it y, x, and 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So here positives. Going to the left, we're dealing with negative numbers. Going up on the y-axis, we have positives. Going down on the y-axis, negative. Negative 1, negative 2, negative 3, negative 4, and so on. So on x-intercepts, here we have point negative 4 comma 0. So that's the x-intercept, negative 1, negative 2, negative 3, negative 4 comma 0. And for y-intercept, we have point 0 comma 4 over 3. So 0 comma 4 over 3, 4 over 3 is 1, 0.3 repeating, so somewhere here. So we have x-intercept and we have y-intercept. When you connect them and then extend it, we're going to have the equation of the straight line. So you don't need to create a table if you have intercepts. Next, what I'm going to talk about I'm going to talk about horizontal and vertical line test. So that will be objective 4. Horizontal and vertical line test. Oh, not line test, just horizontal and vertical line, not test yet. that will be later with functions. Okay, so let me give you the definition of vertical line. A vertical line, that's the line which goes up and down, okay, can be represented by equation x equal k, where k is a real number. Like example, x equal 2. That's it. It's a vertical line. Now, let me give you the definition of horizontal line. So a horizontal line just clean up my computer screen. Okay. So horizontal line. So that's the line from the right. Okay. Can be represented by equation y equal k. The same idea, k is a real number. An example, y equal -3 is a horizontal line. So for horizontal line, you have just y equal to a real number. For vertical line, you have x equal to a real number. Okay, let's do example with horizontal and vertical line. So let's do the example of graphing horizontal line. So graphing horizontal line. So we have graph y equal -2. Okay. So horizontal line. So what we know about horizontal line? Okay, horizontal line. Again, that's the line which goes from left to right. That means must cross y-axis. So how are you going to graph it in this case? You're going to okay. So note what we're going to do. We're going to find -2 on the y-axis, which is technically the y-intercept, and draw the horizontal line. And draw the horizontal line, which will cross the point 0, -2. So I'm giving you a lot of details because for some reason when students have to graph the horizontal line, or vertical line, they're graphing a point, okay, which is not correct. So we're going to find -2 on the y-axis, so 0, -1, -2. So this is just the point, which is the y-intercept. And now we have to draw the horizontal line. So you're going to draw the horizontal line which cross point 0, comma, -2. So this is the graph of y equal -2. So the solution of this equation is every single point which is on the horizontal line. So every single point here has the y coordinate equal -2. Next example will be about graphing vertical line, which is the same idea of graphing. So graph a vertical line which has equation 3x equal 12. Okay, so what you're going to do? So first, you want to solve this equation for x. So we have to divide both sides by 3 and we're getting x equal 4. So your vertical line wants to be x equal to a number. Okay. And next what you're going to do, you're going to find point x-intercept on the x-axis and draw the vertical line. Which cross the x-intercept for okay. So vertical line, forget that's the line. So let's just make the same idea. Minus the point. So find x equal 4 on the x-axis. 1, 2, 3, 4. That's x-intercept of the vertical line, and vertical line you will draw the vertical line which intercept the point 4, comma 0. So this is the graph of x equal 4. So every single point on this line is the solution of that equation. Okay, and every single point on this line has the same x coordinate. Okay, and technically that's it of section 11.2. So 11.2, we only talk about how to graph linear equation in the form of ax plus by equals c. We talk about how to find the x and y intercepts, and also we talk about how to graph verticals and horizontal lines, and that's it. So the next recording will be from section 11.3, when we're going to talk about slope of the line, which most of you probably remember. But knowing the slope of the straight line, also we can graph the equation of the straight line very easy and very fast. So thank you so much for watching.